So, the vacuum dehydration oil purification system, or VDOPS by Oil Filtration Systems, is the industry standard for purifying and maintaining cleanliness of hydraulic and lubrication oils across the globe. Whether you're removing in-train gases, emulsified free and dissolved water, or particulate contamination, the VDOPS is the choice for you. Many things make VDOPS the first choice, but one of the things that makes it the best choice is the reliability and ease of use of our system. In today's webinar, I'm going to speak a bit about the key factors that make our unit so reliable, as well as the preventative maintenance you can do to keep this system operating as intended to maximize uptime of your critical equipment and extend the life of your VDOPS. So what happens if I don't maintain my VDOPS, right? Premature failure of critical components such as the vacuum pump, scrambling to get needed components in a hurry, right? Here at Oil Filtration Systems, we do our best to stock all of the critical components that are needed for our equipment. But in today's climate and with the way that supply chains are, it's hard to know exactly if we're going to have everything that is needed in stock at all times, right? Unplanned outages due to high moisture or particulate contamination, right? Your dehydrator goes down and you don't know how long it's going to be down, how long it's going to take to get it back up and running. And you don't know if you're going to have any critical rotating equipment failures due to high particle count or moisture content. Cost of expediting components or rental equipment. It's not just the cost of the components themselves that may fail, but the cost of getting it there quickly, hot shots, overnight freight charges, etc. Right? And then, of course, undue stress and pressure. Right? Everybody's got somebody above them that's going to be potentially yelling at you if you've got some piece of critical equipment down. And I don't know about you guys, but I definitely don't need people yelling at me on a daily basis. That's for sure. So first and foremost, I would say the most important, the vacuum pump, right? It's the beating heart of any vacuum dehydrator, and without it, you might as well have a 1 to 2 ton paperweight. There have been many different styles of vacuum pumps used over the years, but the best and most reliable vacuum pump used on vacuum dehydrators today is the claw-style vacuum pump, of which Oil Filtration Systems was the first to utilize. It doesn't require a second utility such as water to run. It's not as maintenance heavy as a rotary vane vacuum pump, and even in the toughest, wettest applications, will perform as intended to keep your dehydrator running. However, there are two main factors in keeping the claw-style vacuum pump running. The first is the vacuum pump oil, which should be changed out at regular intervals of 5,000 hours, or when the oil is seen to be dark in color or milky when excess moisture is ingested. Let's go outside and take a look at a vacuum pump oil changeout.
Just like the beating heart requires blood, a vacuum pump needs lubricating oil to continue operating, so changing the oil is a must in extending the life of your VDOPS. The process is simple and can be performed by a single person in a matter of minutes. First step is to remove the drain plug from the side of the vacuum pump. Remember to place a drain pan to catch the dirty oil. You can also remove the oil fill cap to help speed up the draining process. When the oil is no longer a steady stream, you can put the drain plug back in. Using a funnel and a quart of new vacuum pump rated oil, begin to fill until the oil level on the sight glass reaches halfway. On top of changing the oil, the second most important thing you can do is to spray WD-40 or another petroleum-based solvent into the service vacuum pump port located at the air inlet of the vacuum pump. This will help to lubricate the claws as well as remove any rust and varnish that might build up on them. Remember to spray the solvent while the vacuum dehydrator is running, and to spray 2 to 4 1-second sprays to make sure it ingests enough.
Continuing on to the vacuum discharge coalescer, which is the oily mist eliminator as well as the silencer for the vacuum pump. It is recommended to replace these elements in 2,000-hour increments, whether it is the standpipe style with the felt wrap element or the new cartridge style elements. There are times when this element and canister may become saturated with moisture and needs to be changed out more frequently. This will have to be determined by a visual inspection, especially recommended when excess moisture and vapor is seen emanating from the discharge coalescer.
Change out is simple, but should be performed when the dehydrator is not running, as to avoid the hot air that discharges from the vacuum pump. While this element is not essential to the running of the vacuum dehydrator, as I stated, it will cut down on oily mist and act as a sound silencer for the vacuum pump. It is recommended to always use genuine OEM replacement parts when performing a PM on your dehydrator. This will ensure better performance, longer lasting components, and will not void your warranty.
Next, we have the air inlet filter. The air inlet filter plays a very important role in the VDOPs. While the filter itself does not help or hinder the vacuum dehydration process, it does filter and clean the metered outside air that is brought into the vacuum chamber.
This outside air is used to perform the process of mass transfer, which is, in essence, is the culmination of dry outside air coming into the vacuum chamber to pick up and help remove the moist vapor that has been removed from the oil. The typical recommended change-out interval is every 6 months, but sometimes sooner in applications where there are large amounts of airborne particulate matter floating around.
While on the topic of filtering, the next most crucial item in need of change-out during a PM is the particulate removal filter element. Our vacuum dehydrators use a high-efficiency pleated microglass Beta 1000 rated filter element to help remove particulate contamination from your oil to meet or exceed ISO cleanliness standards on a wide range of applications.
While our units use a differential pressure gauge to determine when the filter is plugged and needs to be changed, we still recommend changing the filter every 3 to 6 months of continuous use, even if the filter is not plugged. This helps to maintain the quality of the filtration needed to meet industry standards. Choosing the right filter to meet your desired ISO cleanliness requirements can be a difficult task, and when faced with this decision, it is recommended that you speak to your local oil filtration systems product specialist to help you in choosing the right filter for the job.
One last item of interest, which is not a maintenance item per se, but instead a feature of our VDOPs that helps to make it so reliable and easy to use, is our permanent dispersion media, or PDM. The PDM is located in a basket inside of the vacuum chamber and is made up of stainless steel rashik rings. These are designed to maximize the amount of surface area inside the vacuum chamber so that as much oil and water mixture as possible interacts with the vacuum dehydration effect inside the chamber. Now, while the industry standard for many years was to use costly coalescer elements inside the vacuum chamber, OFS pioneered the use of PDM to not only save the operator time and money, not having to change out coalescer elements, but also to prevent the flow restriction that is caused by using coalescer elements on higher viscosity gear oils. Our VDOPs does not ever need to have the PDM elements changed out, and they will last for the life of the unit. So not only do we manufacture units that are easy to use and set the standard for reliability, but we also rebuild and upgrade other manufacturers' units to meet these same specifications.
Things like replacing the electronic control panels from old relay style controls to newer PLC controls to allow for easier troubleshooting, as well as adding redundant safety features and variable frequency drives for better, safer operation. We replace old liquid ring vacuum pumps, which require water to operate, as well as rotary vane vacuum pumps, which are much more maintenance and breakdown prone, to claw style vacuum pumps, which require much less maintenance and are better equipped to handle dirtier, wetter applications. We also replace old style process heater elements with dilapidated or insufficient heat shielding to low watt density heaters, which give better delta T and reduce the chance of coking of the oil. Last but not least, we replace the existing coalescer elements in the vacuum chamber with maintenance-free PDM elements that never need to be changed out, and in some cases, replace the vacuum chamber entirely to the oil filtration systems vacuum chamber, which gives better visibility and surface area.
Thank you very much, guys, for joining us today. I know that was fairly short, but in essence, we manufacture these dehydrators to make them as maintenance-free as possible. There's other small little items that you might perform during a PM, but when it comes to extending the life of your vacuum dehydrator, these are by far the most important things that you need to be looking at. So if you guys have any questions or anything else, you just let me know. I think you can send it to the chat, correct? And we'll get you guys answered.